All right, here we go with looking at part 2 of how we use division and powers together in the same sorts of problems. The second property is the power of a quotient. So if we have a quotient, that is if we have something being divided in parentheses as our base, and we're raising that base to the nth power, what do you think that equals? Well, it's similar to the power of a product property that we saw. We have to apply this exponent to both pieces of the base, both the numerator and the denominator. So this is equal to a to the n over b to the n. And this is applicable as long as a and b aren't 0, and n needs to be an integer. So here's an example. We're going to look at 2 examples, and we're all done today. Our task is to simplify this. What we want to do is we want to look at each piece of the fraction independently. And by each piece, I'm talking about like the regular numbers, the x's, the y's, the z's, because this is all multiplication. So how I'm going to choose to look at this is 8 over 2 times x to the 4th over x to the 4th times y to the negative 1 over y to the negative 5 times z to the 8th over z, and that would be z to the first. So now we simplify each one of these little fractions. Very manageable. 8 divided by 2 is 4. These are regular numbers. We don't use exponent properties. We just do regular arithmetic with it to get 4. X to the 4th over x to the 4th. If you recognize that as something divided by itself, you can write 1. Otherwise, you can write down that it's x to the 0 using our exponent property. Then we go on to our y's. Here we have y to the negative 1st over y to the negative 5th. So we need to subtract those exponents. Negative 1 minus negative 5 minus a negative gives us positive. So we have y to the 4th times, now z to the 8th over z to the 1st. We subtract the exponents, z to the 7th. And we clean this up, x to the 0. That guy, that's just 1, so we have 4 times 1, or just 4, y to the 4th, z to the 7th, and this is our simplified expression. Last example, we're going to look at this 2 different ways. Why don't you pause the video, though, and see if you can't get to a simplified form, then restart it, and see if you did something along the same lines as I did. All right, so one thing we can do is we can take this exponent, this negative 3, and apply it to the numerator, apply it to the denominator. And when we apply this exponent to the numerator, we have to apply it to both pieces up there because there's actually 2 things being multiplied. We're going to have 2 to the negative 3rd times x to the negative 18th. Exponent to exponent, we multiply, and that negative 3 has to go to the 2, and it has to go to the x term. The denominator we'll have y to the negative 12th, again multiplying those exponents. Now we look at the different pieces in the numerator and denominator. What we see is that everything has a negative exponent, which means everything needs to move. The base of 2 has a negative exponent. Currently the 2 resides in the numerator. It's going to get sent to the denominator. It will become 2 cubed. Our x power, that has a negative exponent. It's currently in the numerator. It's going to go down to the denominator also. We'll have x to the positive 18th. And similarly with our y, our base of y has a negative exponent. Currently it's in the denominator. It's going to jump up to the top. We have y to the 12th. And there's one last thing to do to simplify this. We have y to the 12th over 8 x to the 18th. That's one way that we could have chosen to attack this problem. Another way that we could have done it would be to say, okay, I see that the exponent's negative. I have a fraction as my base. The negative causes the base to turn over. So I'm going to rewrite this as y to the 4th over 2x to the 6th. And now this is raised to the 3rd power. The negative reciprocal took the reciprocal of the denominator. Now we have all positive exponents, and we're going to get right to there. Either way is fine, it doesn't really matter. And as you start to encounter more complex expressions, you're going to come to realize that there are multiple ways, multiple correct ways to work through these things. And it's going to kind of depend on what you latch on to doing first or see to do first. That's going to determine how you choose to work through these problems.